Hello friends, Namaste. I am Bhavik Joshi and today we are going to study about the subject of basic transportation engineering. We have conducted lots of lectures before this on basic transportation engineering. We have conducted lectures on road structure and today we are going to study about components and structure of railway track. Have you ever wondered guys what lies between those tracks and what lies beneath the components of the railway tracks? Yes, today we are going to study about all those things. So let us dive into that straight away and start our lecture of today. That is the structure of the track and the components of a railway track. First of all, let us observe a sketch of a railway track. Here you can see a railway track and its components. First of all, we can see the rails that lies on the top of the structure. Beneath that, we can see sleepers on which it rests. We can see fastenings which are holding those rails with those sleepers. Beneath those sleepers, there are sub-ballast and subgrade. This is a very simplified form of a railway track, but we can also study the detailed description of these components. So let us see one by one what these components have to offer us. First of all, the rails. Now we have seen these rails so many times. There are plenty of types of rails. As you can see over here, the top portion is known as rails. That is our first and foremost component. In rails, what is the function of rail? First of all, we need to understand why we lay a rail. Now, there are many types of rail as well, but let us see for what these rails are used for. This is the part of rail, as you can see. I have indicated with a blue mark. Now, the rails provide a smooth and continuous surface for train wheels, allowing them to move along the track. They offer a smooth surface, friends, and also a continuous surface on which the train wheels will rotate. Also, they can rotate on these rails without getting disturbed and also allow them a direction in which they have to move, right? So this is the function of the rails. Now let us see of which materials these rails are made of. These rails are made of high strength steel. You know, you have always seen these rails in day to day life, and we can see these rails shining because they are made of high strength steel to handle the stress. Yes, friends, they can handle all the stresses of the train, all its weight, and all the load coming on from the train and the passengers that are sitting in the train. Now, let us see the types of these rails. First of all, flat-footed rails, most commonly used. These are the most commonly used. We have seen these rails in day-to-day lives. Now, with a wide base that rests on the sleepers. So these flat-footed rails, as we can see in this picture, it is resting on these sleepers. These sleepers are made up of concrete. We know that we have seen these cement concrete sleepers wherever we travel, right? So before that, wooden sleepers were used beneath these rails, but they used to get rotten. So nowadays, concrete sleepers are incorporated. Now, we can see more of its types. Bull-headed, common in older designs with a rounded shape. There were also rails like bull-headed. They were called bull-headed because they had a shape of a bull. That's why they were called as bull-headed. Then there were another type of rails that's double-headed, less common, with two flat sides. They were having flat sides and they were very less common. They were very less used, that means. Okay, for increased durability. Wherever they used to use this bull-headed, sometimes they used to use double-headed. Wherever they needed durability, wherever they needed them to be strong. Okay, now let us move on to the next part, that is sleepers. Now let us see sleepers function. Sleepers, why are sleepers used? As you can see in this picture, The part beneath the rails are sleepers. These are made of cement concrete, as you can see over here. Now, as supporting structure of the rails, they support the structure of the rails. They help the rails to be at a place and at a distance that is determined. Okay. Now, they maintain the correct spacing. Now, it is also necessary that the correct spacing between the rails are maintained. Okay, and help distribute the load from the train evenly across the ballast. Now, we have to understand that these sleepers over here not only keeps the rails at a distance which is necessary, but also holds them in position. Also, they are distributing all the loads that comes from the rail into the lower layers. Okay. Now let us see the material that are made of. Wooden sleepers. As I told you, in previous ages, they were using sleepers made of wood, traditionally used but can be prone. Now, what are the disadvantages? They are prone to wear. Okay, they can get weathering. If they cannot withstand weather, also their pest will eat them up. Okay, so nowadays we don't use wooden sleepers. Concrete sleepers, widely used today for better durability and uniformity. Nowadays we are seeing that concrete sleepers are used. Why? They are durable. They can withstand the temperature. They can withstand all the weather conditions. That's why. Now, steel and composite sleepers, less common but used in some regions for the strength and durability. Now, these are less common sleepers, but they are extremely durable. So wherever it is necessary that we need strong and durability, we need to use them. Okay. Now, arrangement. How are these sleepers arranged? Sleepers are spaced evenly and laid perpendicular to the rails, as we can see in this picture over here. These sleepers are laid perpendicular. These are the sleepers. As you can see, it is laid perpendicular to the rails. Okay, as I have marked over here. Okay, now, arrangement. Yes, that was the arrangement of them. Now, the distance between the sleepers is typically around 60 centimeters to 70 centimeters. That is 24 to 28 inches. Now, what is the distance between the sleepers? Each sleeper, if we are laying a sleeper, for example, then we need to leave a space of 60 centimeters. Okay, only then we can lay another sleeper, depending on the track time. Okay, so these were the sleepers. Now, let us understand the next part, that is ballast. A function of ballast. What is the function of ballast? Now, beneath the sleepers are the ballast, as we saw over here. The ballast portion. Okay. Now, let us understand. It is a crushed stone or gravel placed beneath and around the sleepers. So, they are laid beneath and around the sleepers. Okay. So, they will be laid below the sleepers, also around of it. Okay. Its primary function is to provide stability, prevent track displacement. It will stabilize those sleepers. It will not allow them to move. Okay. Also, what will they help in? Track displacement. They won't let the track to get displaced and allow for water drainage to keep the track dry. Okay. So, why are we laying those ballast beneath the sleepers? There are many functions of it. One is that load distribution. They will take all the load from the sleepers. Another thing is that, what are they saying? That they will help those sleepers be in position. Also, they will not absorb water. They will let the water flow easily. They don't absorb water, they don't store water. Okay, and they don't get wear and tear from that weather condition. Now, material, crushed stone or gravel. For that ballast, we are using crushed stone. We will crush the stone and we can use over there. Or simply, nowadays we see gravel stones over there. Okay, which we get from various quarries. Chosen for its angular shape to interlock tightly and prevent movement. Okay, why they are chosen? Because they have an angular shape. Okay, they are angular and they can interlock tightly. They can get interlocked tightly. So we are using it. And another thing is that they will prevent the movement. They won't let the movement to happen. Okay, they will hold those sleepers in position. Now, benefits: load distribution. They can easily distribute the load. Ballast help distribute the train's weight and force across the track and subgrade. They will take all the load from those sleepers, and what will they do? They will distribute evenly on the below portion of it. The below portion of it is subgrade. Okay, now drainage. It allows water to drain away from the track. It is allowing all the water to drain away because it does not let it to stay over there, or it does not even absorb. It will absorb, but in little portion. Okay, that could lead to track instability. Okay, now next portion, track alignment. The ballast helps keeps the track aligned over the time, reducing maintenance cost. Okay, it also reduces the maintenance cost. How does it reduce the maintenance cost? Because they let the track aligned how they should be in position. Okay, now let us see the next portion. So over here we can see the ballast. If I'll show you with my pen, these are ballast, these were the sleepers, and beneath that this is the ballast portion. Okay, I hope it is clear. It is made up of gravel. Nowadays we see that this ballast made up of gravel are laid below these sleepers, around and beneath them. Okay, so no water is absorbed, everything is drained. Also to keep the upper portion in position and distribute the load evenly. Now let us understand the next portion, that is subgrade. Now the function of the subgrade. The subgrade is a natural ground or engineered material. See friends, we need to understand the portion of the subgrade. Okay, there are also sub-base portion or sub-ballast portion wherever necessary below the ballast, but if it is not necessary, then the next portion will be subgrade. Okay, so what will it do? We need to understand it serves as a fundamental support for the entire track structure, as a foundational support. It serves as a foundation. Now in buildings we know we prepare a foundation on which the upper portion or the plinth level or the lintel level, that is the upper floors, rest, and all the load is sent and distributed into the ground, into the subgrade, into the foundation. So that is the portion of this subgrade, that is the function of this subgrade, if I say. So it is like a foundation for the railway track. What will it do? It will take all the loads coming from the upper portion. Upper portion means the rails, the sleepers, the ballast. It will take all the loads coming from them, and it will absorb all the loads and distribute it evenly into the ground. It is the ground portion, if you will say. The ground portion or the foundation portion is known as subgrade. Now what is the material of it? Typically consists of compacted soil. It is a compacted soil or engineered fill that provides the necessary. Friends, we need to understand that this is the soil, but it is a compacted version of it. Okay, the compacted soil or the engineered. Okay, sometimes we need to mix certain ingredients with the subgrade, just that so that it makes itself strong enough. It is strong enough to resist all the loads and to take or absorb all the loads. It has to be up to the safe bearing capacity. It should be like it should bear all the loads from it. So we need to prepare it well. We need to level it well. We need to give it a proper slope. Only then and then the rest of the things will be laid on it. Okay. Now, so load bearing capacity has to be ensured that it bears all the loads. Now, design consideration. The subgrade must be properly prepared. Okay, and leveled. As I told you, it has to be leveled. It cannot be up and down. To prevent settling, it should not get settled in let us say rainy season. Okay, or in any season if it shrinks or warps. Okay, which could cause track misalignment. If the subgrade is not proper, if the subgrade settles down, then all the structure will collapse. All the structure means, as you saw, ballast, the sleepers, the rails will collapse. Okay, and it will be a major problem. Okay. Now, in some cases, the subgrade may be reinforced with additional layers like geotextile or stabilizing materials. Now, we can also lay geotextiles on it so that we can make it a bit stronger. Also, stabilizing materials, we can add certain materials to make it even more stronger, so that it can resist, it can absorb, it can take all the loads coming from the ballast or the sleepers or the rails. Okay, so we need to prepare this subgrade such that it acts as a foundation. Now, what does a foundation? It takes all the loads. So we need to get it ready for that, and we need to do whatever it takes to make it as strong as it is necessary. Okay, to take all the loads from the upper portion, that is the ballast. Okay, friends. Thank you so much. Now today we will conclude our lecture till here. Now once more we will just revise the things that we have studied over here. Okay. First portion is the rails. We have seen the rails that absorbs all the loads coming from those trains. Now we have seen that these rails are made up of many materials. Okay, these rails can be made up of cast iron. These rails can be made of steel. Okay, now these rails has to be kept at a specified distance, and it has to be gripped well so that the trains can run on it smoothly and it can take all the loads from it. Okay, now they are kept in position by these fastenings, as we saw over here. These are the fastenings. These are the fifth portion of it, the fastenings. These fastenings will keep them in position, will keep them holded to those sleepers. Now all the loads from the rails will go into the sleepers, and the sleepers will take all the pain. Now these sleepers are made up of, these are the sleepers, friends. These are the sleepers. Okay, these sleepers. Now these sleepers are kept at 90 degrees to these rails, and these sleepers will hold these rails in position at a distance necessary. Also, it will absorb all the loads from it. These sleepers are used to be made of wooden, but nowadays they are using it of cement and concrete. Now beneath these sleepers are a portion of this ballast. This ballast will absorb all the loads coming from these sleepers. Now this portion, okay, it is made of crushed stone or gravel. Gravel that we see in our day-to-day life, gravel is used in all types of construction. Okay, they are laid around and beneath these sleepers to take all the load. Okay, now beneath that is subballast that will take the load of ballast. Okay, as I told you. Now beneath subballast and ballast, the final portion is subgrade. That is the soil, that is the compacted or the leveled soil that will take all the load from the upper portions. Okay, then it has to be a firm soil. It has to be a soil of safe bearing capacity. Okay, to take all the loads from above. Okay, so these were the portions. Okay, the last portion was fastenings. Let us also see the fastenings. As I told you, friends, fastenings are the equipments which are holding those rails in position with the sleepers. They are tightened with the rails. They are tightened with the rails and the sleepers, and they will hold the rails in position. Function are the components that secure the rails to the sleepers. They ensure the rails are fixed in place, preventing movement or shifting under the load of passive trains. We know that the trains are moving at very high velocity and speed. Okay, so these fastenings keep the rails in position with the sleepers. Types of fastening: fish plates, steel plates that connect the ends of two rail sections. Now the types of fastenings are, there are fish plates, okay, which will keep these rails into position. Rail clips that secure rails to the concrete or steel sleepers. Okay, if it is a concrete or steel sleeper, this will clip them. Okay, this will clip the rails to the sleepers. Spikes or bolts are used to fasten rails to wooden sleepers or steel ties. If it is a wooden sleeper, then we will use spike or bolts. Spiring or elastic clips provide an additional tension, ensuring the rails stay in place despite the forces exerted on them. Okay, now you will provide additional tension necessary so that the rails stay in place despite the forces, whatever the forces comes on it. So these were the things, friends. I hope you understand whatever the components we have saw today and the structure of the rail track. First of all, let me revise once again the rails on which the trains are moving, and the rails are taking all the pains of the load of the trains. Beneath that are the sleepers at 90 degree. Okay, 90 degree to the rails that are keeping them in position, and these rails and sleepers are kept in position by these fastenings. Okay, so that the rails does not move. Even the speed of train the rails are kept in position at a high speed of train, should I say. Okay, now below the sleepers are the ballast, which are made up of gravel, okay, which will take all the load from the sleepers, and there is a portion of sub ballast which will then distribute the load that is coming from the ballast, and the last portion is subgrade, which will act as a foundation, as a foundation. And what does foundation do? A foundation takes all the load from the upper portion that comes on and distribute it evenly on the ground, and it has to be compacted and level. So this was the entire thing of the components and structure of railway track. I hope you understand. Thank you so much. I'll come back to you with some more interesting topics next time. Thank you for watching.